Hi, everyone. I just wanted to let you know, and I'm going to cover this again later in the session. Um, I am going to be doing two Zoom sessions. One will be for periods 1, 2, and 3. The other one will be in periods 5, 6, and 7. Okay, and those sessions will only last about 15 minutes long. I will record them so you'll be able to view it on Edsby if for whatever reason you're unable to see it. But I strongly encourage you to either join us. I would prefer if you did, because there are some things that I need to discuss in regards to work that is becoming a problem. So, hi. So, I don't see everyone in here yet, or a good chunk of the people who are probably going to join us. So I'm going to come back to that in a little while and go from there. But what we're going to do right now is I'm actually going to go over the assessment questions. I'm going to post it in Edsby. I'll come up with the time in a little while. Right now, I want to wait until more people get in because then I'm repeating myself. I'm going to go over the assessment questions for activity 75. Once we go over the questions for activity 75, I am going to go over the question. I'm going to go over activity 80. Okay. It's not a lab or anything, so we don't have to worry about that just yet. I believe activity 81. Activity 81 is the last activity, and it is a lab. It is the last activity before our test. Now, we are going to spend some time doing a lot of review. I'll be giving you a review sheet on Edsby, of course. So don't worry about not being able to adequately prepare for the test. I'm going to make sure that you can adequately prepare for the test. Okay? So, activity 75, the first question was, identify a place in each graph where the slope of the line changes. What does a change in the slope of a motion graph indicate? Okay, so just to show you what the graphs look like. Okay, this is Tisha's, for example. Okay, you have the slope change from here to here, from here to here. Okay, you can see this slope is different than this slope. I have not given the time yet, Kip. I said I was going to mention it later when more people were in the session. So, when you're looking at the change of slope in a line, what does it indicate? Anyone have a guess? Okay, it indicates how fast you're moving. Okay, so it indicates a change in the distance traveled over time. So the faster you're going, the greater distance that's traveling over time, the greater distance you're covering in the same time frame. If you're moving slower, the less distance is being covered in the given time frame. Okay. Okay. So, Gabby, is anyone else having an issue with audio, or is it just Gabby? Yay or nay? Anyone else having an issue? Okay, so, all right, so then I just wanted to make sure it wasn't coming up on my end. Okay, all right. So, the speed, can you turn that light on, please? The speed No, we're not throwing you under the bus. We just want to make sure that you could actually hear it. And, maybe if you're able to go back, you'll be able to see it. But there's no throwing people under the bus here. So, a change in slope indicates a change in speed or a change of distance that is covered over a period of time. Okay, so which student, Tisha or Josh, started out faster, and explain how you know this? Okay, so Tisha started out faster, and the reason you would know this, if you look at Tisha's slope, in a period of 6 minutes, she managed to cover 3 miles, but in a period of 6 minutes, oh, my son turned the light back on. In a period of 6 minutes, Josh was only able to move a matter of 2 miles. So Tisha was going faster than Josh was. Okay, so in the same amount of time, she was able to travel a greater distance, so she started out faster. Okay? Just what company are you talking to me? Now. Hi. All right, I'll have to go back and look at the Activity 75 video. I know that there were a couple that I had to do 2 videos. Okay, so looking at number 3, how far into the trip did Josh turn around? Describe what the graph looks like at this point in the trip. So, okay, thank you. So try that, Gabby. So at which point did Josh turn around? Since this says distance from home, you probably are having trouble reading it. But since this says distance from home, Josh was 2 miles away from home, and at this point, he turned back around and dropped down. So it would be when he returned home. So it would be around the 6-minute mark, he turned back around and went home. Okay? Now, number 4, look at the motion graph shown below. Match the descriptions here to the correct graphs. A car is moving at a constant speed and stops, and then moves in the opposite direction at the same speed. Okay, that would be graph 2. Okay, that's what we're looking at here. He went to a constant speed, he stopped, and then went back at the same speed. It took him about 3.5 minutes to go, and then 3.5 minutes to come back. Okay, so I'm not going to cover that until I finish going over the questions. Now, a car is moving at a constant speed, moves faster in the same direction, and then stops. Let me go ahead and get those graphs for you. Okay. Let me pull the questions out of my book. It'll be a little bit easier to see. All right, so activity 75 questions. All right, so this actually looks just like Josh's trip right here in that portion. Okay, and then the second part said the car is moving at a constant speed, stops, and then moves faster in the same direction. That would definitely be graph number 4. It's moving at a constant speed, it stops, and then it accelerates. So it's moving in the same direction at a much faster speed. Okay? The next question says a car is moving at a constant speed, changes to a higher constant speed. Now this is without stopping. So that would be right here. Okay? Graph 1. All right, so he's going at a certain speed and then accelerates, and then a car is moving at a constant speed and changes to a lower constant speed. So in this particular case, the slope of the line diminishes. It's going very fast, and then it slows down. Okay? So, does anyone have any questions on that? Okay. All right. So now that there are more people, let me go ahead and mention, and I will probably do the Zoom classes about a half an hour after we get out of this class. Okay. I can't give you a time until we're about to dismiss from this class, so I can give it to you towards the end of the period, and I will post it on EDSB. And again, first, second, and third period will be in one Zoom session, and fifth, sixth, and seventh will be in another session. And the reason for that is because the maximum Zoom will give you is 100 participants, and we all know I have more than 100 kids. I will let you know towards the end of the period when it is, but please understand that it's important that we do this and that you actually listen to what's happening in Zoom, because I've seen some issues with homework assignments and things like that, and I need to make sure I cover it so that people understand it. Okay? All right, so looking at activity 80. That's what we're starting today. Yes, it is today, Luke. All right, so activity 80. Know that activity 79 questions are due. Please make sure you're paying attention to when your assignments are due. Look at the assignment in EDSB, and please pay attention to when it's due. Okay? All right, so 80 talks about Newton's laws of motion. There are 3 laws of motion. Okay? So, Newton's first law is the law of inertia. Probably. Just makes sense. Yes. So, 79, I believe I put due on Thursday, and we'll go over it Thursday. Okay? And then 80 will be due on Friday, and we'll go over it on Monday because we don't have class on Friday. So, but tomorrow you have 76, and I know 77 and 78 are coming due. I believe 76 and 77 are due the same day. So please make sure they're done. So, looking at force and motion, Newton's first law is law of inertia. Now, you saw that yesterday when we were spinning the marble around loop. Okay, and when you're spinning that marble around the loop, you see that the marble continues to go in the direction of the circle because it is forced to go through the direction of a circle. No, you cannot send homework assignments through EDSB. It has to go into the link, and I will explain why in the Zoom messages. But briefly, when you email me an assignment, I have been getting hundreds of emails. So assignments get lost there and I don't see them. That's why I don't want assignments emailed. I want them to go through the EDSB. That way, when you go, when you submit it through EDSB, it shows me that the assignment is there. And I'm going to explain all of that when I do the Zoom. That's one of the main reasons why I'm doing it. Okay? So, the law of inertia is when it's the propensity to go in a particular direction. Okay? So if you're in a car, for example, and you're driving, okay, and someone slams on the brake, you're going to go forward. Why? Because you were already moving forward. When someone slams on the brake, instead of moving forward, the car is now going in a negative direction and you are continuing to move forward. Okay? Now, if you look at, if you're at a stopped position and the car takes off, when the car takes off, you go like this because you were in a particular position and now that motion has changed the position that you're in. Does that make sense? Okay, so that's inertia. When we were going around the circle, Okay, the marble was going in a particular circle, but it was trying to continue going in its direction and the circle was blocking it. So when the circle was open, now all of a sudden that marble had a path that it was able to take off. Okay, so that path it took off in the direction that it was facing at the time that that circle was no longer there. Okay, and it just continued to go. All right, so that is the law of inertia. So it takes a force to overcome an object's inertia and make the object go faster, slower, or change direction. So if an object is moving, okay, in space, if an object is moving in space, it's going to continue to move in the direction it's moving unless an outside force is preventing it from doing that. Gravity is an outside force. So all of the planets that are orbiting the sun and all of the satellites that are orbiting the planets are doing that because they are held in place by a gravitational pull. The gravitational pull is preventing them from traveling in their direction. If the gravitational pull were to let go, whatever direction that planet was trying to go in, prior to that gravitational pull being cut, is the direction it's going to go. So if it's going like this and then it's cut, then it's going to go like that because that's the last direction it was going in. Okay? So that's pretty much what inertia is. It's the tendency to continue going in the same. And usually inertia, you feel inertia when you're trying to overcome it with a force. The plastic circle that the marble was hitting was overcoming that force. When you're driving in a car, the acceleration overcomes the force of you standing still, and then you go like this. When you're braking, that brake overcomes the force of the movement forward, and you go like this. Okay? So, now on Earth, we have obviously gravitational pull. We also have friction. Okay, frictional forces. I don't know why you guys are hitting a lag, just to let you know. I actually had someone come out and redo all of my stuff. So my speeds are actually really high right now. So I don't know why anybody else would be hitting a lag. But my stream is going really well. Usually when you guys tell me you hit a lag, I get a message that says that I had a problem with my stream. But I'm not getting any messages. It's actually moving really, really well for me now. So, all right, so frictional forces. Okay, if you're rolling a ball, for example, we were rolling that in a container. It'll slow down because it's rubbing against the cardboard. If we didn't have the barrier, it would continue to go and then eventually it would stop. Okay, and the amount of movement that it has, that movement, what it's rubbing on will dictate how much. Okay, I was just checking my microphone. That amount would dictate how much, the frictional force will dictate how fast it's going to slow down. Okay, we talked earlier in the year about the coefficient of friction. For example, if you were trying to roll a marble on a carpet, it's going to slow down a lot more than if you were to try to roll it on, let's say, a hardwood floor, okay, or on a tile. Okay, so looking at balanced forces, okay, a balanced force is when you have two forces that are going in the same direction and they're pressing equal and opposite to each other. And the result of that balanced force is that there is no net movement. Okay, so if I'm pushing my hands together like this, this is a balanced force. Both hands are applying the equal force to each other, and therefore my hands aren't moving. However, if you do this, Now I know it's going to the left for you, but my right hand is pushing on my left hand with a greater force than my left hand is pushing on my right. If you missed a minute or two, don't worry about it. You can always go back and watch the video. If you watch the video, it'll show everything that's there. Okay, so don't worry. This video will be up for you to be able to watch. Okay, so a balanced force is when the net force is 0. If I apply pressure to, let's say, this juice bottle, the bottle's not moving, and neither is my finger. That is a net force of 0. The force that my finger is applying on the bottle is equal and opposite to the force that the bottle is applying to my finger. Now, if I did this, the force that my finger is applying to the bottle is greater, and that is a unbalanced force. Okay? Does that make sense? Everybody with me so far? Yes, no, maybe so. Okay. So now, Newton's second law is the relationship between mass, force, and acceleration. I posted a video on that yesterday. I also, that's what we did when we did the lab, force equals mass times acceleration. And we were looking at, the activity where we were looking at the formula F equals ma, and we were looking at the data tables, so on and so forth. Okay, so I did go over how to use that formula, and you will get a worksheet on that. But the bigger the force that is applied to an object, the greater the resulting acceleration. Now, if I have a shopping cart and I push the shopping cart, if I push it with a little bit of force, it's going to apply a light force to a shopping cart. It's going to move a little bit. If I apply a huge force to the shopping cart, it's going to move a lot further and it'll move faster. But now let's look at mass. If I take one empty shopping cart and one full shopping cart, and I apply the exact same force to both, which cart is going to move further and why? Anyone? I'll repeat the question again. If you have two shopping carts, one full, one empty, and you push both of them with the exact same force, which one is going to go further and why? Why do you think the full one's going to go further? Okay, justify your answers, because I'm getting both. It's lighter. That is correct, Gabby. If you apply the exact same force to the shopping carts, the light one is going to go further because there's less mass to overcome. Cassie, you couldn't have said it better. That is perfect. The empty one has less mass to hold it back. Okay? Think about it. If you want to push something to make it move, the lighter one is going to be easier to move and you apply less force. If it's heavier, in order to get it to move further, you have to apply more force. If it's heavy, you have to do more work. You have to apply more force to make it go. Does that make sense? For those of you who thought it was full, does it make sense now? Well, if it has less stuff, it has less mass because all matter contains mass. Mass is the amount of matter something contains. No, they're not hitting each other. You're applying the same force to both. Which one is going to move further? So I'm standing here and I've got a shopping cart here going that way, and I've got a shopping cart here going that way, and I apply the same exact force to both. Which one is going to travel further? That's what the question was, Ryan. Does that make sense? Okay. All right. So that is Newton's second law. Okay. And we already talked about unbalanced forces a little bit. Well, if you put a ton of force behind the full one, it'll go further. However, we're applying the same force to both. So the only thing that's different is the mass. Amberly, you may want to check what your settings are. I know some change their settings and it's not lagging anymore. There are no issues with the internet connection. So you may want to check to see what your settings are. Okay. What do you mean it's more mass to keep it going? The question was, when you apply that force, which one is going to move further? More mass doesn't keep it going. In fact, in this particular case, applying the same force, more mass is actually going to decrease it because gravity is pulling down on it. And as a result, that gravitational pull is going to increase the frictional force between the cart and the floor, and it's going to slow down. So it's not going to continue to go. You're not applying a constant force. You are applying one initial push. In that particular case, the lighter cart, the empty cart, is going to go much further because that cart has less of a frictional force between itself and the floor. And okay, but you're talking about if the circumstances are right. The question simply stated was, if you apply the exact same force to both carts in a push, which one will travel further? That is what it is. There is no, you're applying a constant force to one and not to another. You're applying the exact same force to both. Okay? So, now, Newton's third law, with every action, there's an equal and opposite reaction. Okay? Great example of this is Newton's cradle. I love Newton's cradle because in Newton's cradle, when you pull one of the balls and let it go, it's going to knock into four of them. One is going to go this way at the same height, and then they're going to continue. If you pull two are going to come up. It's really cool because there are 5 balls in a standard Newton's cradle. A Newton's cradle it's basically 5 balls on 2 strings. The strings are held like this, and it's in the center. And there are 5 of them that are next to each other. And when you pull one and let it go, it pretty much goes tick, 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 tick. And the great thing about it, yes, that's what it's called. So and look it up, see what it does, because if you were to pull 4 and just leave 1, when you drop it, when it hits that 5th ball, 4 of them are going to go this way. So for every action, there's an equal and opposite. You can find a video on Newton's cradle. I will upload one to Edsby. It is a pretty cool device because it demonstrates that law very, very well. Okay. But it basically shows that when an object applies a force on a second object, the second object applies the same force in the opposite direction. Okay. So if my hands go like this, at the point that they struck each other, they applied the same exact force to each other, but in opposite directions. Okay? So now if you kick a soccer ball, at the point of impact, your foot hits the ball at the exact same force that the ball hits your foot. Now, what happens after that obviously is depending on the object, okay? If you kick a wall, you're likely going to be breaking your foot. But the force you applied to the wall, that wall applied that same force to your foot, okay? So that's basically what Newton's third law is. Does that make sense? Okay, does everybody understand how that works? Okay, so what I'm going to do, and just to let you know, I'm going to explain this. When I assign the assignment, in the assignment, I'm going to have pictures of, oh wait, I'm actually going to have the questions in there, but what I will do is I can attach a document in there. So I will actually attach a picture of the reading. I know some people are having trouble accessing their online textbook. Okay, so you should be able to see it. And I'll do the assignment after we get off so that I can explain what it looks like in Zoom. But some of you may have seen, for example, with activity 75, when I assigned it, there were actually pictures of the assignment in there. If I can't put it in the assignment, then I will put it directly in the feed. So you will actually have pictures of the entire reading if you want to look at it to do the work, okay? That way it'll help people who are having trouble accessing the online textbooks still have the reading available to them, okay? So now, to go over this really quickly, ladies and gentlemen, we are going to have a Zoom session. I am going to post it on Edsby. That's what I'm talking about right now. I am going to post the times for the Zoom session. Time on deck right now is 12:32. I'm going to host the first Zoom session at 1:15 and the second one about 1:30. Okay? I expect it's not going to take longer than 15 minutes. The whole point is for you guys to see what it is that I want to show you. Because a lot of people have been sending me, oh no, I'm not going to show video. The only person who's going to have their video on is me. We've been asked not to do that, and I'll explain that when we do Zoom. I don't want people coming for both, and the reason for that is because I can only have a maximum of 100 students in Zoom, and I have 178 kids registered to me. So I'd rather you stuck to the Zoom that was associated with your period, okay? So I will post the invitation and the link and the time. And that way you'd be able to join us, okay? Like I said, I don't plan on having it more than 15 minutes. Yeah, they'll probably be like, hopefully there'll be more than 30 people, but the fact remains is that the maximum I can have is 100. So, does anyone have any questions, comments, anything that they need help with? Okay. So what I'm going to do is I'm going to end the stream, and I'll post the homework. And then from there, if you have any question, go ahead and ask them. Yeah, but a lot of people have a tendency of watching the stream after I get out. Within an hour of my stream yesterday, it was like 100 and something views, 147, I think I saw. So it could be that people are just waiting for it to end and then watch it that way. But like I said, we're going to do 1:15 and 1:30. I'm going to post the homework. Take a look at it. I'm going to post, I'm going to post the invitations and go from there. Okay? Yeah, period 6 is the second meeting. Periods 5, 6, and 7 are the second. Periods 1, 2, and 3 are the first. All right, so I will see you guys at the Zoom meeting or tomorrow. Please make sure you watch it if you're unable to attend, because I am going to post it on Edsby. Okay, I'll see you later.